This is the band energy diagram of the materials. To explain the conductivity properties of these materials, band theory of solids explained in this way. Like all the first energy levels in these materials, suppose if I have taken an atom, let us take silicon. Not only silicon, any atom we can take. So it, as the atoms exist in group, all the first energy levels they comprises an energy band. All the second energy levels they comprises a energy band. All the third energy levels they comprises one energy band. So from now onwards, instead of talking about the energy levels, we'll be talking about the energy bands. So the first band, second band, the third band, if it is the last one, that is called the valence band. Every energy band is separated by a forbidden energy gap. There is some gap between the first energy band and the second energy band. In every atom, this case exists. That is what quantum mechanics is saying. Energy levels are not continuous, they are discrete. The outermost band is called the valence band. So this is our valence band. In this valence band, the highest energy of the valence band is called the valence energy level EV. And to carry the current, the electrons need some energy. That energy is called the conduction energy. So these energy levels, the energy which needed by the electron to carry current. So this band is called the conduction band, and the minimum energy level of this conduction band is EC. The gap between this valence band and the conduction band is the energy gap EG. Mostly we are interested in this energy gap only, not other energy gaps. Because to carry current, electrons have to be present in this conduction band, and the electrons generally will be in the valence band. To move these valence electrons to the conduction energy level, we have to supply this much of energy. So that's why we are concentrated mostly in this energy gap. So this energy gap is the difference between the highest energy level in the valence band, that is EV, and lowest energy level in the conduction band, that is EC. Because more than this EC, all the electrons will possess this conduction energy. So to more than this EC to any energy level, the electron may go. All these will carry current. So EG is given as EC minus EV. EG is given as EC minus EV. This is what the band theory is telling to explain the conductivity properties. Here in this case we can say there are no electrons in the conduction band, and this is the case at 0 Kelvin temperature. So at 0 Kelvin temperature, all the semiconductors will act as insulators. At 0 Kelvin temperature, all the semiconductors will act as insulators. So there will be no electrons in the conduction band. So basing on these valence band and the conduction band, once again let us see the classification of the materials, that is conductors, insulators and the semiconductors. So basing on this band theory, the conductors and the semiconductors are classified as, see, in conductors, the valence band and the conduction band overlap each other. That means whatever the valence electrons are there, they itself possess the energy of the conduction band. So these electrons, they are possessing the energy to carry the current. Conduction energy they are possessing, so they will carry current easily. So the band theory tells like the conduction band and the valence band overlap in conductors, whereas in semiconductors this valence band and conduction band are separated by an energy gap EG. If this EG is less than 3 electron volts, then this acts as a semiconductor. So here for a silicon it is given the energy gap as 1.1 electron volts. For germanium it is 0.67 electron volts. For gallium arsenide it is 1.41 electron volts. So this is the energy gap between the valence band and the conduction band. As if this gap is very small, if we supply some an external energy to these electrons, the valence electrons, they gain that energy and they move to the conduction band to carry current. So the electrons which are gaining the external energy and moving to the conduction band, those number will be very less only, no? So very small amount of current that is carried in the semiconductors. Then the next category, insulator. Insulators, the gap between the valence band and the conduction band, if it is greater than 5 electron volts, the electrons, they cannot move to the conduction bands because they have to gain large amount of energy. So they cannot move at all. Very rarely any one electron or two electrons, they may go into the conduction band, and very small amount, very minor amount of current, that too in very rare cases and also in very rare atoms. This insulator, the electrons will be moved. So in insulators, almost we can say the current won't be passing. In semiconductors, very small amount of current. In conductors, very large amount of current, because conduction band and the valence band are overlapping each other. Now we are concentrating in this semiconducting materials, because nowadays in our communication purpose or in the well advanced technology what we are enjoying these days, in all the instruments like our cell phones, laptops, the iPads, the tabs, all these are designed, and the smart TVs, all these are designed with this semiconducting materials only. So let us see in detail about these semiconducting materials.